Namaste everyone. Welcome to the third lecture of polynomials. This is Rajesh, and in this lecture we will learn remainder theorem and solve exercise 2.3. So let us start with remainder theorem. Let Px be any polynomial of degree greater than or equal to 1 and let a be any real number if Px is divided by linear polynomial x minus a, the remainder is Pa. Okay, so Px is a polynomial of degree greater than or equal to 1 and a is a real number, and we are dividing this Px with a polynomial x minus a. We can divide by any linear polynomial x minus a, x plus a, x plus 5, x minus 10, right? The remainder will be P of a. Now see, x minus a, if I am dividing by x minus a, so remainder is given by x P of a. What is this a? A is 0 of this linear polynomial, x minus a. Now what is 0? 0 is that value of x which gives me this expression as 0. So a minus a is 0. So I am putting a here in place of x. Now let us understand this with the help of an example. We consider Px as x cube plus 1 and let us divide it with x plus 1. Now by using long division, here it is x cube. So this x cube I will divide by x. I will get x square. So that will be quotient. So I write x square here. This x square will be multiplied by this x plus 1. So when it is multiplied by x, I will get x cube. When it is multiplied by 1, I will get plus x square. Now I subtract. So after subtraction, x cube minus x cube will give me 0. And here I have minus x square plus 1. So minus x square plus 1. Now in the next step, we divide this minus x square with x. So when I divide this minus x square with x, I will get minus x. So the next term in the quotient is minus x. Now I multiply this minus x with this x plus 1. So when this minus x multiplied by x, I will get minus x square. When this minus x multiplied by 1, I will get minus x. So let us multiply. This is minus x square and here it is minus x. Now again I subtract. So I change the sign. Here it is plus. Here it is plus. So minus x square plus x square will give me 0. And here it is x plus 1. Now this is x and this is also x. So x divided by x will give me quotient 1. I will keep on doing this step again and again till this term have the degree less than this divisor. So as the degree of this term is this expression is 1 and the divisor also has degree 1. So I will continue. Now this one is multiplied by x plus 1. I get x plus 1. And after subtraction, I will get 0. So what is remainder in this particular division? I am getting 0 as the remainder. Now let us verify this with the help of remainder theorem. In remainder theorem, we said that P of A is the remainder. Now P of A, in our case, the value of A is minus 1 because minus 1 is 0 of this linear expression. So we will take P of minus 1. It will be minus 1 cube plus 1. Minus 1 cube is minus 1 plus 1. I get answer as 0. So this verifies the remainder theorem. So I hope you are now understand this statement, remainder theorem. Okay. Now let us see the proof of this remainder theorem also. So Px is a polynomial with a degree greater than or equal to 1. Suppose we divide this Px by x minus a. The quotient is Qx and the remainder is Rx. So I will write this Px as x minus a into Qx plus Rx. Right? Divisor into quotient plus remainder. Now since degree of x minus a is 1 and the degree of Rx is less than the degree of x minus a, so the degree of Rx will be 0. Therefore, we can take Rx as R. This remainder has degree less than 1, so this remainder will be a constant term. So in place of Rx, we write only R. R is a constant term. So therefore, Px will become x minus a into Qx plus R. Right? Now, if I take x is equals to a, then I get Pa equal to a minus a into Qx plus R. This a minus a is 0, so this whole term will become 0, and I will get P of a is equal to R. So we have understood the proof of remainder theorem also. Now let us solve exercise 2.3, which is based on this remainder theorem. In this first problem, we have to find remainder when x cube plus 3x square plus 3x plus 1 is divided by x plus 1. So here Px is x cube plus 3x square plus 3x plus 1, and 0 of this x plus 1 is minus 1. So P of minus 1 will give me minus 1 cube plus 3 into minus 1 square plus 3 into minus 1 plus 1. After simplification, I get answer as 0. So I will say that by remainder theorem, 0 is the remainder when x cube plus 3x square plus 3x plus 1 is divided by x plus 1. Now let us see the second question. Here we have to find remainder when x cube plus 3x square plus 3x plus 1 is divided by x minus half. Now for this x minus half, 0 is plus half, so I will find P of half. P of half is 1 by 2 cube plus 3 into 1 by 2 square plus 3 into 1 by 2 plus 1. So result I will get as 1 upon 8 plus 3 upon 4 plus 3 upon 2 plus 1. Now I will first make denominator same. LCM is 8. So I multiply this second term by 2, this term by 4, and this fourth term by 8. So I get answer as 1 upon 8 plus 6 upon 8 plus 12 upon 8 plus 8 upon 8. Now denominator is same, so I will write denominator as it is, and numerator I add 1 plus 6 plus 12 plus 8, that gives me 27 upon 8. So by remainder theorem, 27 upon 8 is the remainder when x cube plus 3x square plus 3x plus 1 is divided by x minus half. Now let us see the third question. Third question, here we have to find remainder when this is divided by x. Now for x, the 0 is 0, so I replace this x by 0. I will get P of 0 as 1. So I will say that remainder is 1 when x cube plus 3x square plus 3x plus 1 is divided by x. The fourth problem, here we have to divide by x plus pi. Now the 0 of x plus pi is minus pi, so I replace x with minus pi. I will get P of minus pi as minus pi cube plus 3 pi square minus 3 pi plus 1, and this is my remainder. There is no need to substitute this pi with 22 upon 7 or 3.14. So I will say that by remainder theorem, minus pi cube plus 3 pi square minus 3 pi plus 1 is the remainder when x cube plus 3x square plus 3x plus 1 is divided by x plus 1. The fifth problem is we have to find 0 when the polynomial is divided by 5 plus 2x. Now for 5 plus 2x, 0 is minus 5 divided by 2. So I will replace x with minus 5 divided by 2. I will get result as minus 27 upon 8. Now see, here also we first make the denominator same and then we calculated the numerator. So I will say that by remainder theorem, minus 27 upon 8 is the remainder when x cube plus 3x square plus 3x plus 1 is divided by 5 plus 2x. Now in the second question, we have to find remainder when x cube minus ax square plus 6x minus a is divided by x minus a. Here the px is x cube minus ax square plus 6x minus a, and 0 of this x minus a is plus a, so I will find p of a. Now p of a is a cube minus a into a square, that is a cube, plus 6 into a minus a. So this a cube minus a cube cancel, 6a minus a is 5a. So 5a is the remainder, right? In third question, we have to check whether 7 plus 3x is a factor. Now, when I say that 7 plus 3x is a factor of 3x cube plus 7x, when I get remainder as 0. So let us again find remainder by dividing 3x cube plus 7x by 7 plus 3x. So for 7 plus 3x, 0 is minus 7 by 3. So in place of x, I will replace minus 7 upon 3. So p of minus 7 upon 3 is 3 into minus 7 upon 3 cube plus 7 into minus 7 upon 3. I will get minus 343 upon 9 minus 49 upon 9. Again, the second term I multiply and divide by 3, so that I will get minus 343 upon 9 minus 147 upon 9. That gives me minus 490 divided by 9. Now this is not equal to 0, right? So I will say that 7 plus 3x is not a factor of 3x cube plus 7x. So in this exercise we have these problems. Here we have seen how we can use that remainder theorem to find remainder when a polynomial is divided by some linear polynomial, and we have also seen a problem like in question number 3, that how we verify that whether a given linear polynomial is a factor of other polynomial or not. Thank you.